Hello, welcome. Today we'll be looking at past questions for material science and we'll start with the year 2016-2017. Prove that the energy by an electron jumping from orbit 3 to orbit 1 and the energy emitted by an electron jumping from orbit 2 to orbit 1 are in the ratio of 32 to 27. So let's do that. Let's calculate for that. So the formula for calculating the energy of an electron in an orbit is given as E equal to minus 13.6 divided by n squared electron volts. Electron volts, EV, electron volts. So let's calculate for that now. Prove that the energy by an electron jumping from orbit 3 to orbit 1 and the energy emitted by an electron jumping from orbit 2 to orbit 1 are in the ratio of what? 32 to 27. First thing, n is the principal quantum number, which can be what? 1, 2, 3, and so on and so forth. And the principal quantum number given in these questions were what? 3, 1, 2. Okay, those were the three principal quantum numbers. So we will actually calculate for the energy in the orbit 1, orbit 2, and orbit 3. Let's calculate for that first. Energy of electron in each of the orbits given in the question. Energy of electron in orbit 1, 2, and 3. This also represents the quantum number, that is n equal to 1, 2, and 3. So when n equal 1, let's calculate for the energy in the orbit 1, orbit 1. So let's go with this formula. Let's go. E equal minus 13.6 all divided by, now my n is what? 1. I impute it there. 1 squared. This gives me what? Minus 13.6 all divided by what? 1. And this is E. The energy in orbit 1 becomes minus 13.6 electron volts. And the energy in orbit 1 gives us what? Minus 13.6 electron volts. So let's calculate for the energy in orbit 2 when n equal 2 for orbit 2. We simply do what? Impute the value of n to be what? 2. Let's just put that there. We have that the energy at that point becomes what? Minus 13.6 divided by 2 raised to power what? 2. 2 squared. What do we have? That E is equal to minus 13.6 all divided by 4. Right? Therefore, what is my E? E becomes minus 3.4 electron volts. Let's call this E1, energy in orbit 1, and call this E2, energy in orbit 2. And finally, let's calculate for the energy in orbit 3 using same formula. When n equal to what? 3 for orbit 3, what is the energy? Let's do that immediately. We recall that E is equal to minus 13.6 divided by n squared, right? Electron volts. The electron volt is another unit for calculating of what? Energy. Okay, let's go. Then we know that for orbit 3, n is equal to what? 3. So we just impute the value of 3 for n here. And we have what? 3 raised to power 2. What would that give us? Minus 13.6 divided by 9. Therefore, my E3 becomes minus 1.51 electron volts. Now, we are not done. We are not done. Since the question says we should look for what? We should prove that the energy by an electron jumping from orbit 3 to orbit 1 and the energy emitted by an electron jumping from orbit 2 to orbit 1 are in the ratio of 32 to 27. So we are actually comparing. Now, before doing that, we need to know the energy difference between orbit 3 and orbit 3 and orbit 1 rather. Orbit 3 and orbit 1. So how do we do that? We simply do what? Subtract. We simply subtract E3 minus what? E1. We get the energy difference between orbit 3 and orbit 1. And also you get what? The energy difference between orbit 2 and orbit 1. So let's go. So energy difference between orbit 3 and orbit 1. The energy difference between orbit 3 and orbit 1. So let's represent it as this. Since we are talking about difference, we are talking about what? A change, right? Change in E. Let's call this 3, 1. Between what? Orbit 3 and orbit 1. So what would this give me? My E3 minus E1. Right? Okay, let's go. So what was our value for E3? Our value for E3 was minus 1.51, right? Minus, then the energy level for orbit 1 was, we got it to be minus 13.6, right? minus 13.6. Okay, let's simplify. We have this minus 1.51. Minus times minus gives you what? Plus 13.6. Therefore, the energy difference becomes what? Becomes what? 12.09 electron volts. So we've gotten the energy difference between orbit 3 and orbit 1. So next up, let's get the energy difference between orbit 2 and orbit 1. Between orbit 2 and orbit 1. So let's see represent this. Let's represent the energy difference as change in E to 1, right? Right? This gives us what? E2 minus E1. So what was our value for the energy in orbit 2? We got that E2 was minus 3.4 minus, and E1 was minus 13.6. So simplifying, we have what? Minus 3.4 minus times minus plus 13.6. Therefore, our energy difference between orbit 2 and 1 gives us 10.2 electron volts. So we are almost there. The next thing we do, we take ratios of the differences between 3 and 1 and the difference between 2 and 1. So just take ratios of this and this, then we are done. That is how we prove that the ratio of the electron jumping from orbit 3 to orbit 1 and the energy emitted by electron jumping from orbit 2 to orbit 1 are in the ratio of what? 32 to 27. So we take ratios, take keen ratios of the difference to this, right? Okay, so what do we have for that? This gives us 12.09 electron volts divided by 10.2, right? So we're almost there, but this is not the value we are asked for. We are asked that we should prove that the ratio gives us what? 32 to what? 27, and we are having what? 12.09 to what? 10.2. So how do we get 32 to 27? We take equivalent fraction. 32/27 is an equivalent fraction of this. So how do we know that? We multiply both numerator and denominator by 2.64. So mind you, I said we do what? We take equivalent fraction of energy differences, which is this. Take equivalent fraction for the energy differences by multiplying with what? 2.64. Therefore, we have that 2.09 divided by 10.2 multiplied by 2.64 over 2.64. So in doing so, we have what? We get what? 32 over 27. Therefore, we've proved, we've gotten that. We've gotten that. So this is it. This is it. That is for your 1B. That is for 1B.